Welcome to another lecture of Mechanics Paper 4. This time we'll be studying in detail October-November 2021, the first variant. Let's look at the first question. The first question says, a bus moves from rest with constant acceleration for 12 seconds. It then moves with constant speed for 30 seconds before decelerating uniformly to rest in a further 6 seconds. The total distance traveled is 585 meter. Find the constant speed, find the magnitude of deceleration. Pretty straightforward kinematics question. It can be related to equation of motion, and it can naturally be done using basic sketches also. So I personally prefer the sketches. So what we do is that we draw a graph, a sketch, and there are three portions in the sketch. The first portion is about constant acceleration. The second portion is about constant speed. It's not drawn to scale. And the third portion is about deceleration. So now the values are such that for the first one, it's 12 seconds. So I'll label this thing as 12 seconds. Naturally, this is time in seconds. This is velocity in meter per second, but don't assume anything. Let that particular speed be v. And what else is there? Another 30 seconds. So 12 plus 30, this is 42. And 42 plus 6 is 48. Now, the simplest method is to use the trapezium formula. The area of trapezium, that is the distance covered, that is half sum of parallel sides. So between 12 and 42, this is 30 and this is 48 multiplied by the height, that is v, equals to how much? That's 585 meters. So when you do the calculation and you plug in the numbers, so you find the value of v, and this value of v comes out to be 15 meters per second. So therefore v comes out to be 15 meters per second. The last part, magnitude of deceleration, that's too basic. That is change in velocity, which is 15, divided by change in time, which is 8. So this is simply 15 over 8, which can be written in decimals. So therefore this comes out to be 15 over 6 actually. It's 42 and 8, the difference is 6. So therefore 15 over 6, that is 5 and 2, that comes out to be 2.5 meter per second square. They're asking for magnitude, so don't plug in the negative sign. Question number 2. As usual, it's about momentum, because momentum is like a fixed thing in every paper. Two small smooth spheres of equal radii, they have masses such and such, and they are saying the value of k is greater than 1. So let me draw the two radii. This is the two particles, spheres. So this is A, this is B, this is A, this is B, and I'm just drawing it more realistically. So therefore this is A, this is B, this is A, this is B, and this is Km, and this is M, and this is Km, and this is M. So they are moving towards each other. A is moving towards B, so that is 6 meters per second. B is moving towards A, that is 2 meters per second. And after the collision, they coalesce and they become one single body. So they become something like this. And now they would have a common acceleration, and that speed would be 4 meters per second. Now it is natural that when you have such a large mass, Km would be greater than M, and such a great speed, so whatever is the direction of A, that would be the direction of A plus B. It would push it in that particular direction. So therefore you would do the working, that is Km multiplied by 6 and M multiplied by negative 2, because it's in the opposite direction, that is Km plus M multiplied by 4. And That is the reason that they have written that k is greater than 1, because it would be pushing it in that direction. So 6 km minus 2 km is equals to 4 km plus 4m. And what exactly are you looking for? You are looking for the value of k. So basically take m common. 6k minus 2k, that's 4k. Take m common, and this is 4k plus 4. So cancels, and you are left with a value. Maybe I think I've made some small mistake, because this is not km, this is m. So let me correct this thing. This is 6 km minus 2m. This is 4 km plus 4m. So take all the m's on one side. 4 plus 2 is 6m, and 6 minus 4 is 2 km. Now cancel the m's, so therefore k comes out to be 3. So that is the value of k. Find in terms of m the loss of kinetic energy due to the collision. Now, before collision, there are two particles. So for particle A, the kinetic energy of A is half into m into v square. For kinetic energy of B, that is again half into m into v square. After collision, kinetic energy of this particle, which is A plus B, that's half into the total mass into v square. What are the v's? That is 6 and negative 2 and positive 4. First of all, I have included this. And then we know the value of k. We can plug in the value of k, but it would be in terms of m. So for the first particle, km is actually 3m. And the second one is m. And then 3m plus m, that is 4m. So add it up, and then difference is the loss in kinetic energy due to the collision. Question number 3. As usual, a simple question of resolution of forces. Resolution can be used for resultant. Resolution can be used for equilibrium. So sometimes the examiner gives a resultant question, sometimes an equilibrium question. Now in this one, they have given us, there are 3 forces, actually 4 forces. System is in equilibrium. So this time it's about equilibrium. And they have given sine of alpha is 3 over 5. So just draw a small diagram like this. And this is 3, this is 5, this is alpha, therefore this comes out to be 4 according to Pythagoras theorem. Sine alpha is 3 over 5, cosine alpha is 4 over 5. We have to work in the exact trigonometric ratios. Now resolve. So when you do the resolution, so this is P something and P something, that's the first thing. Then 24 something, 24 something. And then last but not the least, 36 something and 36 something. Now this theta is with the vertical. So vertical would behave as cosine because that's the adjacent side. So therefore this is P cosine theta. This is P sine theta. This is 24 sine alpha. This is 24 cosine alpha. This is 36 sine. Now this time alpha is over there, so this is 36 sine alpha and this is 36 cosine alpha. Now let me double check. All the angles were with the vertical this time. Okay, so now it's in equilibrium. So for horizontal forces, the right word equals the left word. P sine theta plus 20. P sine theta plus 20 equals to 24 sine alpha plus 36 sine alpha. 24 sine alpha plus 36 sine alpha. What is sine of alpha? That's 3/5 and this is 3/5. So therefore you can make P sine theta the subject. Similarly, when you talk about the vertical forces, those going up should equal those coming down. P cos theta plus 24 cos alpha. P cosine theta plus 24 cosine alpha should equal 36 cosine alpha. That's 36 cosine alpha. What's cosine of alpha? That's 4 over 5. That's 4 over 5. Hence, you can make P cosine theta the subject. So that is the working for this one. No need to find the angle, that is for sure. And you can read the examiner report also. So P sine theta equals to something divided by P cosine theta is equals to something else. Therefore, tangent theta is this thing over this thing. You will find the value of theta and then plug in any equation and you will find the value of P. So that is the working for this particular question. Question number 4. What is this question all about? A particle of mass 12 kg is stationary on a rough plane. So it's an inclined plane and it is rough. So that means friction is there. 25 degrees to the horizontal, a horizontal force of magnitude P Newton acting parallel to the line of greatest slope. So now let's underline, it's a rough plane, 25 degrees, mass is 12 kg, stationary, external force P Newton parallel to the line of greatest slope is used to prevent the particle from sliding down. Preventing, that means it's not sliding down, but it's preventing from sliding down the plane, and the coefficient of friction is 0.35. Draw a sketch showing the forces acting on the particle. So now, let me draw a diagram. And this time the examiner has asked for a diagram. So now let me label the forces. First of all, this force acting this way is P Newton. And then we draw the component, the weight components. This is mg sine 25 degrees. This is mg cosine 25 degrees. And then you should label the angle also. What else should we label? We should label the R and now the friction force. Because it is being prevented to slide down, therefore friction is acting upwards. So therefore F max is acting upwards. These are all the forces that needs to be labeled. Now find the least possible value of P. This is the least possible value of P because if there was a possibility of the particle moving up, then F max would be down. So those are the two options. So over here, first of all, calculate the value of R. So R is 12g cosine 25. F max is mu R. Mu is 0.35 multiplied by 12g cosine 25. And of course, you can use a calculator once the setup is all done, once the equation is all written. And then P plus F max equals to 12g sine 25. Therefore, P is equals to 12g sine 25 minus F max. And now at this point, you can use a calculator with all your taking care of your accuracy, because now where will the calculator be needed as such? It will be needed for sine 25. It will be needed for cos 25. Work in 4 significant figures. So the final answer is given to 3 significant figures. So this thing is all done. Question number 5. Now question number 5 says, a car of mass 1600 kg travels at a constant speed. So now this is about mass, constant speed, straight road, inclined at an angle of sine inverse. Find the change in potential energy of the car in 30 seconds. That's the first thing. Given that the total work done by the engine in this time is 1960, find the constant force resisting the motion. That is the second thing. Calculate in kilowatts the power developed by the engine of the car. That's pretty basic. Given that this power is suddenly decreased or reduced by 15%, find the instantaneous deceleration of the car. Now, this question is about all the three things: its work, its energy, and its power. Now, what will be needed? First of all, let me draw a box with all the formulas in it. So I'll be needing power is rate of work done. That is one thing that I need. And also power is force into velocity, into constant velocity. I also would be needing change in potential energy. I would be needing change in kinetic energy. I would be needing work done against resistance and work done by engine. So these are all the things that I need. First of all, they're asking find the change in potential energy of the car. So since it's up, so since it's going up, change in potential will be positive. That's the first thing. Change in potential is mg sine theta into distance along the plane. So m is 1600, g is 10, sine theta is 0.12, distance is basically distance is constant velocity multiplied by time, that is 600. So this is this distance 600, and that is the answer for this particular part, which comes out to be 1152 into 1000. I'm writing it deliberately like this. This is joules. Given that the total work done by the engine is this much, so this time now I'll be using this equation, that is work done by engine, that is change in potential plus change in kinetic plus work done against resistance. Work done by the engine is 1960 into 1000. Change in potential is 1152 into 1000. Change in kinetic is 0 because constant speed. And then we have work done against resistance. So I can initially make work done against resistance the subject. That is the subtraction between the two, which is 808 into 1000. But this work done against resistance is resistive force into distance of 600. So therefore resistive force is 808 into 1000 divided by 600. And what do you get? You get something, let me grab this thing, 808 into 1000 divided by 600. So that is 1346.67, 1346.67, and rounded off 1350, correct to three significant figures. That is the answer for the second part. The third part, power developed by the engine of the car. What is power? That's either force into velocity, or power is rate of work done. So it's by the engine. So work divided by time. That is 1960 into 1000 divided by how much is the time? So time is 30 seconds and speed is 20 seconds. So time is 30 seconds. Let me write the two. Time is 30 seconds and speed is 20 seconds because sometimes I mix up the two. So this is the power that is produced by the engine. So doing this calculation, this value comes out to be after rounding off 65.3 into 1000 watt, that is 65.3 kilowatt. In reality, the unrounded value, let me also give you that, 1960 into 1000 divided by 30, that is 65333. So this is 65333.33. This is unrounded value. And this one is rounded correct to three significant figures. Now it says, given that this power is suddenly decreased by 15%, so the power is suddenly decreased, find the instantaneous deceleration. So the new power is 85% of original power. So what is the original power? 65333. So 85% of 65333 is, let me calculate, into 0.85. That is 55533. So that is 55533.33. So therefore, the new driving force is power, and power is work divided by time. Power is also, it's written over here, power is also force into velocity. So power over velocity is force. So this is power divided by velocity. So power is double triple five double 3.33 divided by velocity is the same, which is 20. So therefore, it's on an inclined plane. So what are the forces acting on it? So this is the particle, and we have the power over time over here. We have mg sine theta, and we have the resistive force. So this is that needs to be subtracted. So triple five double 3.33 divided by 20 minus mg sine theta, which is 1600 into g into 0.012. Is that so? So that is 0.12, not 012, it's 0.12. So let me subtract it. 0.12 minus the resistive force. The resistive force value was 1346.67. 1346.67 is equals to mass into acceleration. So 1600 was this, and then when you evaluate everything, you get the value of acceleration, and it is coming out to be negative. In other words, the car is decelerating. So therefore, the value of this acceleration is something like negative 0.306. 0.306 meter per second square. Now let's double check. They are asking for deceleration, therefore the deceleration is 0.306 meter per second square, because the word deceleration has a negative connotation. A negative sign is already part of this value. Question number 6. It says a particle P moves in a straight line and from point O and comes to rest 14 seconds later. So now it's not talking about starting from rest, it's talking about when t is 14, v is 0. That's the first thing. What else is given? We have two equations. The acceleration of p is 0 when t is equals to 2. When t is equals to 2, acceleration is 0. Now, first of all, the first equation is pt square minus qt. Therefore, acceleration is the derivative of velocity, which is 2pt minus q. When t is 2, acceleration is 0. So 0 is equals to 2 into 2, 4. 4p minus q. This is equation number 1. Now, what else do we have? In the second equation, if I plug in 14, so now second equation, when t is not 14, 6. When t is equals to 6, v is equals to 63 minus 4.5 into 6. So let me do this calculation. So that is 4.5 multiplied by 6, that is 27, and 63, the difference is 36. Therefore, this is another condition that I have. When t is 6, velocity is 36. Why do I need it? Because I can plug in this one. There are no instantaneous changes in velocity. That means the velocity at 6 from the first equation is the same thing as velocity at 6 from the second equation. So now what will I do? I'll plug in when t is equals to 6, velocity is 36. This is in equation 1. You mean the velocity equation 1, velocity 1. So therefore, 36, that's p into 6 square minus q into 6. Therefore, 36 is equals to 36p minus 6q. Divide by 6. 6 is equals to 6p minus q. That is equation number 2. This is equation number 1. This is equation number 2. We solve simultaneously. So what do we get? So let me get the answer. So after simultaneous equation, you get the value of p is 3 and q is 12. So p is equals to 3, q equals to 12. Therefore, the first equation is 3t square minus 12t. 3t square minus 12t, that is the first equation. Let me simplify it. 3t, t minus 4. So this is the equation that we have. Now it's asking us to sketch the VT graph. So now recently you have seen there has been a lot of emphasis on sketches. So now you have 0, you have 6, you have 6, you have 14. So this is 0 and 2 and 4 and 6 and 8 and 10 and 12 and 14. So that's how the graph is. 0 to 6 is this quadratic. So 0 to 6 seconds is quadratic. Let me first draw this quadratic. So the roots are 0 and 4. First of all, I'm marking that. So 0 is a root and 4 is a root. Secondly, coefficient of t square is positive. Therefore, that's the shape. That is one thing. Now, when t is 6, v is 36. So I also need that. So let me label this thing. Somewhere here is 36. And let me mark when 6 and 36, that is something to be marked. So this is how the graph would look like. Let me grab a purple marker, a thick one like this. It goes like this and like this. So that's how the quadratic graph is drawn. The next part is a straight line. It says 63 minus 4.5t. So now this straight line would be having a negative gradient, and at 14 it's becoming 0. So that's how you draw the graph of velocity in meters per second against time in seconds. So it's all P1, it's all pure maths. And now what else are they asking us? Find the total distance traveled by P during the 14 seconds. So this is a triangle. There are three main regions. Let me label it. Region 1, region 2, region 3. They're asking us the total distance, and that is the thing. So let me just work it on this graph only. Area of region 1, this is part C. That is integrate between 0 to 4. Which equation? The first equation. That is 3t square minus 12t. So that is 3t square minus 12t dt. Area of region 2, that is still a graph. It looks like a straight line, but it's still a graph. 4 to 6, 3t square minus 12t dt. Do not combine this, and this cannot be combined. Cannot be combined. Why? Because this area is below. This will come out to be negative, and then you would remove the negative sign. This area is above the x-axis. This will come out to be positive. So let me label it. This area will come out to be negative. Ignore negative sign. This area is above x-axis, so it will come out to be positive. Be very, very happy. And the third part that you can do using integration, that you can use using a triangle. So the difference between 6 and 14 is 8, and the height is 36. So these are the three things that you will add, and that would be the total distance covered. So that is the working for this particular question. Now let's move to the next question. What is the next question about? So part C is done. Question number 7. This question is about one short question. That means everything is asked once for 8 marks. It's a pulley connected particle. So basically this is F is equals to ma and connected particle question. And what is the first thing that you should notice? The first thing that you should notice is that it's a smooth fixed plane. Angle is 18 degrees, masses are 2 and 3, also seen over there. Angle is there. Distance is 0.45 meter above the ground. System is released from rest. String taut. When A reaches the ground, the string breaks. Or in some scenario, when the particle reaches the ground, does not rebound, string becomes slack. Remember that. Find the total distance traveled by B before coming to instantaneous rest. You may assume that B does not reach the pulley. Straightforward question. First of all, for particle A, if I should label something. So therefore label this thing. No need to label the other component because it's a smooth plane. And now this is blue like this, and this is something like this. Okay, so this is 2G, this is tension, this is tension, this is 3G sine of 18 degrees. R is not needed, mg cos theta is not needed. This one is going down, this one is going up. So therefore 2G minus tension is 2A. Tension minus 3G sine 18 degrees is equals to 3A. Equation of the system 2G minus 3G sine 18 degrees is equals to 2A plus 3A, which is 5A. Use your calculator, and the value of A comes out to be 2.146 meter per second square. What is the velocity gained? So V square is U square plus 2 into 2.146 into 0.45. So when you have this thing, this velocity comes out to be 1.3897, so 1.390. So velocity is 1.390 meters per second. That is the velocity gain. Now, what happened after string breaks? So after string breaks, there is no tension because there is no string. So therefore, this same equation can be applied for this particle. So therefore, 0 minus mg sine theta, that is 3g sine 18 degrees, is equals to 3 multiplied by a. So therefore the 3 and the 3 cancels off, and acceleration is minus 10 sine of 18 degrees. Use a calculator, and then you find the new acceleration, which is negative 3.090. Negative 3.090. Now for this part, the velocity will now become the initial velocity. So u is 1.390, acceleration is negative 3.090, our final velocity is 0, and v square is equals to u square plus 2 into minus 3.090 into s. So over here you'll find the value of s. This value of s comes out to be 0.312. There is another s to be found that is based upon this. So therefore, that is not based upon this, that's already given. So therefore, the total distance, that is equals to 0.45 plus 0.312. You add it up, and this comes out to be 0.762 meters. So that's how this working is done for this particular beautiful question, question number 7. And that finishes this November, October 2021 paper 4 first variant, which is 41. Stay tuned for more.